Cool, thanks. So our second speaker tonight is Marco Troisi. He's also hosted me at the Waterford Tech Meetup, which is another great meetup. Go down to Waterford and go to it sometime. So Marco is going to talk about serverless architectures tonight.
Hi everyone. So serverless is a term you may have heard of recently, also called or known as function as a service, although that's just a really small part of a much bigger story, which is the serverless story. So how does a serverless system actually work, and is it something that we should be interested in? My name, as mentioned, is Marco. I'm a senior software engineer for ServerLess. I'm also an AWS certified developer and solutions architect. And as mentioned, I'm going to be talking about serverless. So firstly, we're going to look into what serverless is, not just from the perspective of how the vendors, your AWS, your Google, and your Azure, and all the others, how they present it to us, but we're going to try and go, in the limited amount of time that we have, trying to go a little bit deeper than that and trying to sort of get an idea for ourselves of what serverless is all about. And then secondly, we're going to be looking at some use cases. And I'll try to give you some guidelines, more or less strongly opinionated, if you will, but hopefully they will help you or your organization kind of in understanding whether you should make the move to serverless or not. And then lastly, I'm going to give you an insight into our experience at ServerLess with moving from what used to be a big fat monolith to what today a stack that's fully run on serverless. So understanding serverless. Let's start with how it is presented to us by the vendors, the people that are trying to sell it to us. So obviously, the people who probably made the idea of serverless popular in the first place were the AWS guys with Lambda, which was the first and most popular function as a service sort of product out there. And the way they have been, I think probably from day one, the way they have been sort of trying to sell Lambda to people, it's been this. They use this slogan, which says run code without thinking about servers. So they're trying to kind of make it look like it's something that you can just focus on your sort of your code, your business logic, and you don't have to spend too much time on how you actually execute that code. What's the underlying infrastructure? Another slogan that they use is this one, that you pay only for the compute time that you consume. So there is, if this is true, then there is a clear, very strong economic sort of financial argument that you can make for serverless. If you can only pay for when you actually use your, when you actually run your code. I also quite like, so Google Cloud, they have sort of the equivalent of Lambda, which is Cloud Functions, and it's, for all intents and purposes, it's exactly the same with some different languages supported, but it's the same concept. I also quite like the way they were selling it at the start. I think they've changed it recently, the slogan, but for a while it was this one, a serverless platform for building event-based microservices. Kind of a more architectural take on it, if you will. So, kind of putting these sort of three slogans together, you have the idea that you want to run your code without thinking about underlying execution. Then you have the idea that you only pay, kind of pay as you go, pay only for what you use. And then you have the idea that it's got to be something that's event-driven or event-based. And now on to the kind of what what serverless actually is beyond what they're trying to tell us. And I find that there is this tweet that is I think it's one of probably the most enlightening resource out there on our quest in trying to understand what serverless is all about. And I don't know if everyone can read it from the back, but it says if your PaaS can efficiently start instances in 20 milliseconds that run for half a second, then call it serverless. So there's a couple of ideas in there. It's quite a profound sort of statement there. So first of all, for those of you who are not familiar with PaaS, it's platform as a service. So you think of, I think Heroku, probably the most sort of popular platform as a service solution out there. You think also of maybe OpenShift from Red Hat. It's basically the idea that you pay somebody to provide you the system, the tools, and the software already configured and ready to use for you to just upload your code and run it. So you don't have to worry about setting it up. You don't have to worry about maintaining it from an infrastructure perspective. You don't have to worry about security. There's a whole bunch of things that you don't have to worry about. You just pay these guys to worry about those things for you. You just upload your code and it gets executed. So that's what platform as a service typically is about. So this is the first concept idea that's in that tweet. And the second idea is this notion of servers that start in 20 milliseconds or less. I think it's fair to say that when we say that, we don't really mean physical servers. In this day and age, we mean either virtual machines, virtual servers, or probably we also mean containers. And when it comes to containers, I think everyone who's worked with Docker, can you start a Docker container in less than 20 milliseconds? Well, yes, for the most part, most containers, unless they're terribly overbloated, they will start in less than 20 milliseconds. They will start very quickly, and you will run your code very quickly. So this is all to say that there's a couple of sort of concepts and a couple of sort of technologies here that meet each other and turn into what is kind of laid the foundations for, and these two things have been around for a while, and they have laid the foundations for what is serverless today and kind of the serverless revolution, as some people call it. So sort of these two notions. So I think it could be maybe a bit of an oversimplification, but you could think of serverless as Heroku on steroids. So if you think of Heroku, you think of this platform where you just upload your code and it just works, but on steroids, much faster, starts up really quickly, and also you don't pay for when it's idle, for when it's not running. If you think of that, it kind of gives you some perspective on what serverless really is. It's nothing really magical. They're not doing any black magic in there. They're just putting together technologies that have been around and that we know from different sort of settings. So do we need serverless? I think one of the, as I said, while thinking of serverless as Heroku on steroids can be an oversimplification, I think it is also helpful in kind of helping us make the move towards serverless. Why? Because if you use already a platform as a service solution, then you're already in that kind of mindset where it doesn't bother you to delegate some of the configurations and some of the maintenance of your servers and your tools and the fine-tuning of your database. It doesn't really bother you to delegate that to somebody else, to pay someone else to do it for you, in exchange for freeing you some time that you can use to actually work on the business logic of your product. So if you're in that kind of mindset, I think the jump to serverless is a much easier one. Whereas if you or your organization really care about being in control of absolutely everything, not just the code, but also the underlying infrastructure, then I think the mental shift towards serverless is a hard one. So if sort of you are in that place where those things don't really bother you, when should you use serverless? When should you kind of consider migrating what you have towards serverless? Couple of sort of ideas here. First of all, if you're already doing microservices, the jump towards serverless will be much easier for you. And luckily, this is the Microservices Meetup, so hopefully, can't imagine if you're doing monolith what you would be doing here tonight. Just kidding, but obviously, this is if you're already doing microservices, it means that you're already in the mindset of things like infrastructure as code, perhaps because you have to deal with multiple services, multiple small services being deployed at different times. You're already in the mindset of either setting up APIs for the various microservices that you have, or maybe having messaging queues to allow the various microservices to talk to each other. So you have kind of all those things in your tool belt that you know how to use them, and it's not a big deal for you. So it's kind of the jump towards serverless for you is a bit easier if you're already in the microservices world. Then if you have microservices and you have some of your services that are not always on, they're not long-running, constantly running processes, those are good sort of candidates for becoming serverless functions in this particular case. So that's also something that kind of to keep in mind. You wouldn't want in the case of, for example, Lambda, there's a timeout of 15 minutes. And it's been recently upgraded. It used to be just 5 minutes. Anything that lasts longer than that, it just won't cut it when it comes to serverless functions. And something that's event-based, event-driven. That's really where serverless shines. Serverless functions shine. It's got to be something that's been triggered by some kind of event, does something, returns something back. That's kind of where sort of the best use case for serverless functions. Now, if you're not doing these are kind of ideas there, and this would be a great scenario where it would be very easy for you to move to serverless. If you're not doing, let's say, microservices, if you have a monolith in your hands, it doesn't mean that you can't go serverless. It's just that kind of the gap there that needs to be filled is a little bit bigger. As I've mentioned, there's certain things you will need to take care of, possibly from a infrastructure, but also from, I suppose, from an internal knowledge within your team. There's certain gaps that will need to be filled before you make the jump from pure monolith to serverless, at least abstracting some parts of your monolith into serverless. So then when not to use serverless, and this is again, if you will, strongly opinionated, or at least somewhat strongly opinionated. It's based on our experience. If you're not already on the cloud, there's people are going to be offended by the statement, but and there are fantastic, on paper at least, open source sort of serverless solutions out there. I personally think that, and if people are curious about this, definitely feel free to ask questions at the end. I'm happy to go more in depth on this point. But I feel that if you're not on the cloud, you're really missing out on some of the biggest benefits of being serverless. So you kind of miss out a lot there. So if you're not on the cloud, and if you have, and I'd imagine in 2018, if you're not on the cloud, it means that you also have strong reasons not to be there. Otherwise, you probably would be already. Maybe your organization, your business, you really care about having everything on premise for some reasons, or also, the other kind of the second point, which it's kind of tightly sort of linked with the first one, is that you don't want to be vendor locked. If you go to the cloud, there is a serious chance that you are going to end up being somewhat vendor locked into the cloud provider that you choose. And if your organization feels strongly about against that, that's also kind of maybe not a great sort of place for you to start using serverless, because that will inevitably lock you into the vendor of choice when you start using serverless. And again, there's more to this. These are kind of based kind of opinions based on our experience. There's arguments kind of against what I've just said here. I do think these are valid points, but there's more there that could be said. Just kind of advisory there. So then moving on to kind of what our experience with serverless was. And obviously, we wouldn't be here talking about serverless if we hadn't done it ourselves. So we, about a year ago, decided to move or to try serverless ourselves as a company. And as I've mentioned at the start, we had a sort of big, sort of fat monolith, all built with Node.js, Express.js being our sort of routing library, Postgres being our database, Redis for caching and some queues that we had, Socket.io for our real-time chats, which is being a chatbot company. That's kind of sort of the almost the fundamental piece of our platform. And so we decided to make the transition to serverless. And the way we made it was, the first thing we did, we identified the easiest components that we could port to serverless, but also the biggest bang for the buck. So in other words, we looked for parts of our big monolith that could be extracted away kind of as easily as possible, but also we didn't look for some parts of our monolith that was utterly useless and unused, because that wouldn't have brought any real advantage. So we looked for something that was being used within our monolith, but was also, maybe because of the way we'd written the code initially, that could be more easily extracted out of the monolith. So we did that for the very first component. We turned it into a couple of serverless functions, a couple of lambdas, and and we were very happy with that. We noticed big sort of improvements in terms of, so first of all, in terms of the workflow for us as developers in building those functions, turned out to be, once we got over the initial sort of hurdles and learnings, there was obviously a bit of a learning curve, different sort of development model. But once we got over those, it turned out to be a much easier, much more enjoyable process to develop lambdas than it was to push anything into our initial big monolith. So that turned out to be a really pleasant experience. But also we noticed how, from a performance perspective, just so much faster. Scalability was no longer a problem. And the other thing is also the peace of mind. So all of a sudden, when it came to those things that we had migrated to serverless, we knew that we no longer had to worry about them crashing or ceasing to work at any point in time. Why? Because you have in our case with AWS, you have the power of AWS powering those functions. So what that means is that I mean, there's no imaginable, I mean, I'm sure there is, but no one's ever hit the amount of sort of traffic that would ever make AWS crash. We're talking about massive scale, and they also scale it for you. They, turn it up and down based on how much traffic you're dealing with. So it's just a huge peace of mind, as opposed to you having to deal with sudden spikes and all those kind of things. So from that perspective, just the peace of mind that gave us, it made us decide that we wanted to move everything to serverless, basically, or as much as we could, which is why, shortly after that, we established a roadmap and migrated everything else. And at this point in time, our entire platform runs on serverless, and we've never been happier. And doesn't mean that there's no issues there, that there's no downsides, but it really has helped us as a company, as a small startup, to sort of get our product, get our business logic out there in a much quicker fashion, because now there's so many more things that we don't have to worry about anymore. And it just scales, and we don't have to worry about any of that. In the process, we realized, and we then decided that we wanted to use everything that the cloud had to offer, because once we saw how good it felt to have our code running off Lambdas and no longer having to worry about the underlying infrastructure, and no longer having to worry about setting up the servers and opening up ports and setting up security and maintaining all that, and having 15 people in your ops team just to deal with that, we realized how good that was, and we thought to ourselves, what else is there that we could just delegate, pay AWS and do it, that they can do it for us? And so we ended up moving kind of virtually everything we had to the equivalent AWS solution. So as mentioned at the start, we had Postgres as our database of choice. We've now moved everything onto DynamoDB, which is highly available, highly scalable, hugely, highly performant sort of database, and it's fully managed for you, so you don't have to worry about anything as far as the underlying infrastructure goes. And it's also relatively easy to use. There's some learning curve there, but it's not too bad. Also, we replaced Redis with a mixture of Dynamo, which turned out to be really fast for those scenarios as well, and also SNS for some of the kind of the messaging stuff that we were doing. And one of the cool moves that we made was that we got rid of Socket.io and replaced it with a service in AWS that's called IoT Core, and that's a service that's meant for handling messaging between IoT devices, but turns out to be absolutely perfect for kind of your typical MQTT scenario, Socket.io scenario, where you have real-time chat and all that. It's got all of that underlying, and again, it's a managed service. Setting it up really easy. You copy this, so you can configure it to be really powerful, but in terms of getting started with it and creating a real-time sort of chat based on it, really easy, way easier than having to figure out anything else on your own. So I think those were the main services I can think of. Oh, the other thing also was that obviously we ended up replacing our sort of routing that was based on Express.js. That was all ported. That was kind of all being done with API Gateway. And API Gateway in AWS is exactly what it sounds. It's the AWS sort of solution for your API Gateway pattern. That also, fully managed, highly available, no scalability problems because it scales up and down. So your APIs are always kind of working and performing as they should. So all of this we decided to really go all in into the cloud, and we kind of made at one point kind of almost a conscious decision that we didn't want, as soon as we, like I said, we saw the benefits initially, and then we started saying, what else could we delegate to the cloud? And we ended up making the decision that we really didn't want to spend a single minute of our time dealing with anything that didn't have something to do with our business logic, our business core, the thing that our customers were paying us for. Why worry about infrastructure and all those things when you can delegate it to somebody else? I think this picture is really funny, kind of explains this point. I don't know if everyone can read in the back, but it's basically these two fellows, and they say, we were 6 months too late to market, and our product didn't have any useful features, but never forget, our Kubernetes infrastructure was utterly beautiful. And I think that kind of sort of summarizes what I've been trying to say, which is, if you spend too much of your time trying to set up your beautiful Kubernetes infrastructure, or your amazingly fine-tuned Postgres or whatever you use database, super secure, super amazing, and you have like 5 ops people working on it. As cool as that is, as entertaining and as great of a learning that may be for people, it really doesn't give your customers anything beneficial at all. Unless, and I'm sure there are some companies where that really is part of their core sort of offering, but other than that, for most companies, especially startups, doing all that work on your own doesn't give your customers any benefit, any advantage whatsoever. So it's in many ways, it's time that's wasted. We realized that when we were dealing with some of our artificial intelligence work. At one point, we came across this number that AWS has apparently something like 7,000 engineers working on their Lex service, which is their NLP engine. So that's for natural language processing. And when we saw that, we were like, here's 5 of us. There's 7,000 of them there. Let's pay them to give us this, to do this for us, rather than trying to figure it out on our own. We never, ever going to make as good a product as they are. Never mind making it even better. So let's delegate that part of kind of our business to them, and let's focus on what's the actual core of what we're trying to do here. So what we've learned in the process, a few good sort of outcomes from our transition to serverless. First one, big cost reduction. I can't unfortunately share the exact numbers, so you kind of have to trust me here on my word, but our build was slashed by 90% from when we were on our big monolith to when we finished our transition to serverless. Costs went down 90%. And I think for most of us involved in the process, I think the more probably optimistic amongst us were probably thinking that, best case scenario costs are going to be more or less the same. Some of us probably thought, once we're hooked into AWS, the bills are going to go up, and once they have us and their vendor locked us in, then who knows what the costs are going to look like. And as soon as we realized how much money we were saving, that was almost like, there was no going back at that point. It was just incredible. We couldn't believe it. From a Lambda perspective, cold starts can be an issue, and that's obviously because when the underlying containers that you run your Lambda code on, when they're cold, they take some extra milliseconds to start, whereas when they're warm, obviously they start up much faster. That's usually an almost imperceivable extra latency that you have, but if you're grabbing content from maybe 5 or 4 different Lambdas and combining the payload and giving back the response to the user, it does kind of add up. So now, if you're doing microservices, in many ways you're accustomed to somewhat account for latency that could go up and down because you have maybe different services, and you know that one service could be down for maybe a couple of seconds, and so you are probably in the mindset of having sort of ways to account for the extra latency gap that could come up here and there. But still, it's just something to keep in mind even when you do serverless. And the solution in that case was a couple of things. One is CloudWatch events, which is really just a fancy way of doing cron jobs. And what you do every few minutes, you hit your Lambda so that it stays warm, so that when the real world request comes, the containers is already up and running and the requests get sort of fulfilled much quicker. And the other thing, the actual non-hacky solution is to give it more memory. The more memory the Lambda has, the more power the underlying container will have to start up quickly. So another thing that we learned was that cold starts after deployments are even worse. So every time you deploy new code onto your Lambdas, the cold starts takes even longer than normally it would. So again, just the case of you taking that into account and building your architecture in a way that whenever there is an extra latency gap, it somewhat deals with it gracefully. 12-factor application, or in the case of serverless, it's actually 7.5 factor. You can look this up. There is a really cool blog on the AWS blog where they talk about the 7.5 factor application, because apparently the remaining factors don't really apply to the world of serverless, but there are at least 7.5 out of the 12 that still apply, and it is a good idea to. And again, if you do microservices, hopefully you're probably already doing 12-factor, and definitely stay in that mindset. Stay in the mindset of stateless and self-contained applications as much as possible, because otherwise with serverless you are gonna run into trouble. All in, as far as the cloud goes, we found that it was much better than being half-hearted. So I've mentioned, we very soon realized that the more we could just delegate to the cloud, the better off we were. So that was kind of one of the biggest sort of takeaways for us. Infrastructure as a code. Again, if you do microservices, hopefully you do this already. But really, when it comes to in our case, we now have like several hundreds Lambda functions. Some of them are grouped into a single repository. Some others are in their own repositories. But you just don't want to have anything here that's not sort of automated and that's not version controlled. It's just it's nearly impossible to manage otherwise. So from day one, just make sure you have infrastructure as code. In our case, we've been using from day one CloudFormation, which is the kind of AWS way of doing infrastructure as a code. Some people use Terraform. There's other solutions out there. So choose one, but definitely do it. And lastly, CI/CD. And I've only got one thing here to say, which is that without automation, good luck. Continuous integration, continuous deployment, if you don't automate it, it's going to become an unmaintainable mess. So absolutely make sure automation is, at least some form of basic automation is in place from day one. You don't want to be pushing and deploying and zipping and uploading your Lambda functions manually. You don't want to do that in the slightest. So, getting to the conclusion, serverless, and particularly in this case, as we've kind of have more of an eye of its function as a service, is most certainly an advancement in the way we operate our servers and the way we build our software, and we should all be excited about it. It is really cool. It can be a sensible choice if you have no issue locking yourself to a cloud vendor, and if your operations are sort of small, critical, intense computing wise, and not always running. it is probably not the best of ideas if you don't want to be vendor locked and if you don't want to be on the cloud. You know, at the end of the day, we're talking about serverless, and if you try to do it yourself rather than do it on the cloud, you'll find yourself setting up all the servers to run your serverless solution, whether it may be kubeless or one of those ones. It feels to me like almost a contradiction in terms. You're trying to do serverless and there you are setting up all the servers, so it doesn't really make sense. So those are kind of I suppose our learnings and some somewhat strong opinions about it based on our experience.